let me introduce to everybody Barbara Nelson, who's the head of applications at InfluxData. And when we talked, her and I talked about what she should talk about at InfluxDays, I was reminded that at a lot of our webinars that we do, when our community members see the dashboards that we push data into, they often ask the question, I just want to take that panel and I just want to put that little panel in my app. And how do I do that? And so I shared that with Barbara, and she's going to answer that question for you guys. So Barbara, I'll let you take it away.
Awesome. Thanks so much, Chris. And yes, that it was when Chris asked me that question, I thought, you know, I probably should figure out the answer to that question. So I lead the teams that are responsible for building the UI for InfluxDB, and also the team responsible for data acquisition, how we get data from Telegraph and other sources into our time series database. And so it made sense that I would be able to talk a bit about both of those things. How do we get the data in, and then how do I render it in my own application? So I took a simple case and said, all right, you know, I should be able to build an app. And I picked an example which was kind of near and dear to my heart in the days pre-COVID. So when I first joined Influx, I've been here about a year now. When I first joined Influx, it was the first time that I was going to be working in San Francisco. And so given the cost of parking in San Francisco, I said, you know, I can take BART. Those of you familiar with the Bay Area, BART is our Bay Area Rapid Transit, or our subway system. BART stations are not the most desirable places to be hanging out in for too long. And so I wanted to get a sense of how frequently trains left the station, to get a sense of how much time I would need to spend hanging out in the BART station. Conveniently, BART has an API that'll give you real-time metrics about train arrival and departures. So with that, that was my kind of high-level approach. I was going to use the BART public API to get real-time metrics. I was then going to use Telegraph to pull those metrics from the BART API and send them to our cloud. And then in the cloud, I was going to model them in our dashboards, and then also model them in a standalone application, a React-based app. And so at a very high level, that was the approach that I took. So starting with the first step, getting the metrics. Fortunately, BART does have a public API, a REST API, that I was able to use. And so that REST API gives you a ton of information. That was my biggest challenge, actually, as it gives you an awful lot more than I could possibly have wanted. You can get schedules, you can get fares, you can get real-time estimates, you can get information about all of the different stations and capabilities, you know, facilities available at the various stations. And then you can get the response back in either XML format or JSON format. Conveniently for us, we can process JSON pretty easily. So I decided to play around with that and see where that took me. So as an example, this is just a partial response. I had to truncate it because it doesn't fit on the screen. But what it gives you is information, which is time series data, which is the time they're estimating. So ETD, estimated time of departure for the next train, in how many minutes it's going to come, the platform it's going to come in on, is running late, is running on time. So, you know, I could have gotten more sophisticated, watching all sorts of other things like the potential for how often it would be delayed, you know, pricing over time, all sorts of things. But I just picked the simplest one, which is, okay, how many minutes until the next train that's headed to where I want to go? And so now I had Telegraph to the rescue. So Telegraph has been mentioned a couple of times this morning, and I have to say, put in a plug for my team. I am immensely proud of the Telegraph team. It's a small team keeping up with a really strong Telegraph community, where we are just getting tons of contributions from the community, which is what has enabled us to, as Ryan mentioned, have over 55 new plugins this year. So it's really impressive to see the work that a very small team can do when they're supported by such a strong community. So anyway, enough of the plugs on my Telegraph team. So Telegraph can very easily pull data from this BART API. So we've got an HTTP input plugin, which calls the BART API, gets the data back. I then used the Starlark processor plugin to do a little bit of cleanup of the data, and then an output plugin to send it to the cloud. So it's this is a really simple data in, data out. Obviously, the plugins can be a lot more sophisticated, and you can write to multiple outputs, you can pull from multiple inputs. Mine was a very simple case. One of the things I did go through, so I thought it was interesting, Kurt was making a comment earlier about the, trying to kind of understand your data. And that actually, I'll be totally honest, this, for a newbie coming to the company who didn't have a strong background in time series data, I did struggle a little with the actual representation of the data and what processing I should be doing at the edge. Telegraph has a lot of power in terms of processing the data. So what should I be doing at the edge versus what should I be doing sending it to the cloud and then process it when I'm on the query side. So there really are trade-offs between what you send, what you pre-process at the edge versus what you send in. So my input plugin is pretty simple. I was actually calling two APIs, one being for any of you who recognize the station names for BART stations, I wanted to find out the estimated time of departure for trains originating in Colma and heading north. So that was orig equals colm and dir equals n. And then I also wanted to get the estimated time of departure for trains heading south from the Powell Street station. So Colma north in the morning and Powell south in the evening. I have to admit, working from home, this is one of the things I do not miss. I do not miss my BART commute, but it was a good excuse to do some work, take our platform and make a real world case that I found entertaining. But yeah, I have to say, not standing around on the Powell Street station is one of the good side effects of us going 100% remote. So we configure the URLs we're trying to reach, the key we're looking for, which is the estimated time of departure. I want the data format. I want to get it back in JSON. And then I navigate that JSON query that I want to find the ETD navigating from route down to station and 0 for the first entry, because I just want the next train. I don't need to know if there are half a dozen trains because I'm assuming I'm going to get on the first one. And then I pick tags for the abbreviation for that's where the station is, and the direction. So I could filter northbound trains from southbound trains. And then the field, which was my, okay, how many minutes until the next train goes by. And so it was a pretty straightforward to figure out how to actually configure this. And it worked like a charm. So I was able to see the data coming in and I was able to pull out the relevant fields. So I wasn't sending all of that information about that the BART API had available to me. I was able to focus on the one that was relevant for me in my case. So then the processor plugin, this one was actually completely optional. I just wanted an excuse to play around with the Starlark processor plugin because we were talking about it. So I did a little bit of cleanup here. Again, this is a case where you could just as easily have sent this to the cloud and filtered it out using Flux. I just happened to decide to exercise our Starlark processor plugin and do a little bit of filtering on the edge. For some reason, this BART API, and I didn't design it, I just use it. For some reason, if the train is leaving right away, instead of having 0 as the estimated number of minutes, they had the word leaving. And so this actually tripped me up the first time when I was first playing around with this. And I just took whatever the string value was and then tried to turn it into an integer. And it worked fine for a while until the next train left the station. And then, and then I got an error. And so this is a real simple example of a primitive Starlock script, which basically says, hey, if the field has the word leaving, turn the field into the word 0. And then conveniently, I can then turn it into an integer, so I can send it to the cloud as an integer. So getting it to the cloud, really straightforward. I pointed it at the URL for my Cloud 2 account with my token. My organization pointed it at my bucket, and off it went. Certainly for my example, I could just as easily been using the open source instance, running it locally. I preferred using the cloud, less for me to install, and a good way of exercising our Cloud 2 service. So I could also, I chose to run Telegraph, my Telegraph instance locally, but I also, that could have been running anywhere because I was reading from a public API and writing to a public API. So there was nothing that was limited or behind, behind firewalls or anything. The BART API was completely public, and the API to write it to our cloud is also equally public. So that was step 1, getting the data into the cloud. And it went pretty seamlessly once I understood kind of the format of the JSON and understood what fields I was actually looking for and where they were, and basically configuring the plugin to identify the particular fields I was most interested in. Step 2 was now analyzing the data. So now let's see what it looks like in InfluxDB. And so I actually started by just looking at the raw data in the query builder. This was because even though I had the mental model for how the data was going to get transformed from Telegraph, it was a lot easier if I could actually see, oh, okay, it is going to be in the field value and where these other fields are going to be and what's in them. So I just found within the query builder, starting with the raw data was quite useful for me to kind of confirm that my data was there and it was in the format that I expected it to be in. So this is just a quick example of what that is. So now I started doing Flux queries. Again, this was new to me too when I was doing all of this. But it was really straightforward. Basically, all I'm looking for is in the time range that I was curious about. I was looking for a measurement called HTTP. And out of that, I was going to filter the southbound trains and how many minutes I had to go. So that's the Flux query in a nutshell on how long I need to wait for a southbound train. This is also a place where, had I wanted to, I could have had the logic around filtering out the word leaving and turning it into a 0. I certainly could have done that in Flux rather than choosing to do it in the Starlock Telegraph plugin. So now it's like, okay, so I knew when the next train was coming, how would I get the average wait time? Again, pretty straightforward. Here's a little bit of Flux that does that. Disclaimer number 1, I am not a Flux expert. I spend a lot of time managing teams that are a lot more skilled in this area than I am. So I was able to do pretty straightforward stuff, but I'm sure there are a lot more sophisticated things that others would potentially do with the same data. And I would also encourage all of you to, if you want to play around with this BART API and see if you can do something a lot more sophisticated than I have. So then step 3 was to make my dashboards. And here is where, we go back to Kurt's comment about, I thought it was just a database, and I thought it was just a database. But in reality, there is so much more that we can be doing in terms of how we visualize this data and all the different ways we make it available. And so I was able to go through our web UI and start playing around with the dashboards to see, how soon is the next train that's heading to Millbrae or San Francisco Airport. So I could see in the evening when the train was likely to go, what's the average time I need to wait for a southbound train or a northbound train, and so on. And so I was using a combination of these kind of line graphs to represent kind of what that data is. But obviously there was a lot more power to this than I was simply choosing to exercise in my app. So now you might say, well, are you finally going to get to the topic of your talk? And halfway in, I am. So what I showed up to now was how to end up with a visualization of some interesting time series metrics in our UI. And we have a lot of use cases where folks want to do that, and they want to use our dashboards, and they want to use our UI to visually represent their data. So then they can just log into our cloud UI and see their data there. But as Chris mentioned earlier, we are also getting a lot of interest from folks who don't want to have to use our full UI, but they want a way of representing and rendering that those metrics inside their UI. And to do that, we have another open source project, which we just GA'd today, called Giraffe. And so for those of you who are developing your apps in React, Giraffe is an open source React-based visualization library. And so Giraffe gives you a lot of ways to visualize time series data in many different representations. So React itself is a JavaScript library for building a UI. We use this every day. This is what powers the graphs in our UI. But this can also be used by itself to power the graphs inside your application. And it is open source. Contributions are more than welcome. We've developed a lot of different visualizations, and I'll walk through what some of those are in a little bit. But there's also a lot of opportunity for others to get their creative juices flowing and offer new visualizations into the project. So to build my React app, this is where disclaimer number 2 comes in. I am not a React expert, and credit to one of the developers on the UI team for helping me even with the most basic application. This is where I occasionally get tripped up with the, how hard can it be to do something I've never done before? But luckily, it actually wasn't that difficult. So there were kind of 3 parts to my React app. The first part is, so I have this data that's sitting in InfluxDB. So I need to connect to InfluxDB to, and then execute the query to get the data, and then display the results visually. So it's very similar to what I would have done through the web UI, but instead I'm doing it inside a React application. So to connect to the InfluxDB, really simple, similar to what you saw earlier when on the Telegraph side. So I have a token that I can use to authorize basically access to prove that I'm legitimately allowed to read this data, pointing at my org, the URL for the host I'm trying to reach, and I end up with basically a reference to a query API that I can use inside my React application. So now I have my Flux query, and you'll see it looks remarkably similar to the query I showed you for the dashboards before, because it is remarkably similar. It is the same. So I'm just taking that Flux query and then calling the query API. And I actually get back, the Flux comes back as annotated CSV, lines of CSV. And so I basically iterate through the getting this line by line, getting all the data back, and setting it in as annotated CSV, which is what my React application is expecting. So my query is exactly the same as if it was in the dashboard, nothing different about it. I'm just running it from my React application. So now I can use that data that came back, my data from Flux, and I can now populate it into, in this case, I happen to pick a line graph with the x-axis being time and the y-axis being my value. I filter out the string types because that's the one I'm looking for. And I am ready to go. And now I can display my results. So I put a label in my for my x-axis and my y-axis, and then I just call plot and with the configuration. So it defines that basically in this configuration, I'm specifying that I want the table that came back, the table data that came back from Flux. I want it to be a line graph, and they're the labels I want. And I end up with this piece of visual mastery. I would not get high marks for graphic design. Our designers are probably cringing at the idea that this is something that I put together. But as you can see, it's basically exactly the same as we had in our dashboard. I get the tooltips for free. I get the the x-axis, the y-axis, all of those things come for free as a part of this. So I had a really simple app that rendered all of this without me having to figure out all the details of how I would do that. So I hope that encourages the rest of you to do something similar. So as I mentioned, there's a lot more to Giraffe than what I pulled out here. I just had a very basic line graph. So I'm actually going to switch gears now to walk you through Storybook, which is the, it's a super cool interface that'll show you all these different visualizations. So let me, no. Can folks see what I have on Storybook now?
Yes.
Awesome. So Storybook comes with our Giraffe project, and it is a really powerful way for you to see all the different visualizations that Giraffe makes available. And you can also play around with them. So, do I want to include the axis or leave it out? Do I want to, let's change the line width to 45. Look at that, big fat lines. So like I say, I don't get high marks for my design skills here. But we have a whole ton of different visualizations. We've got this band chart, which you can customize in different ways. You can have your own CSV, or this test example uses some test data that's populated in it. You can have gauges, I like those. Same thing, so you play around with these and see what makes most sense for you. And you can start seeing the power of how you use these. One of these, which is a recent addition, is in the geo area. And so we've seen some wonderful work coming in from our templates work, mapping metrics to geographical areas. And so these Geo Maps are a way of taking our metric data and overlaying it onto a geographical map, which can give you some really powerful capabilities. So you've got, here I've got one with where I can specify that I want different markers on the map. So suppose I said, well, I actually want more markers. There's lots more markers. I can also go for more like a heat map if I want to see a different different ways of visualizing the data in a geographical area. Maybe I should have used this for BART. Okay, next time around, next time around, maybe I'll show visually where all these BART trains are going. But that's a perfect example. So I can take my data, which was intended for one purpose, and now I can visualize it in a very different way by simply applying a different visualization for the same data. Going to XY plots, probably the more traditional ones that you've seen in the past. One of our newer ones is in Mosaic, where we have, this one was developed by 2 college interns who worked for us over the summer. And they did this visualization to contribute into Giraffe, or of a histogram. So there's really there's nothing that prevents you from either designing your own, but what I found particularly interesting with the Giraffe visualization is how it's a great way of giving kind of different meaning to the same data. So I've got the same set of metrics, but I can really tell a different story. So depending on how we visualize it, you really can tell a very different story for the data. And so this is a way that I would certainly encourage you to think about, how do you tell the story? So for the data you're trying to provide, what tells your story? What do you want to draw attention to, or what do you want to, suppress? As they say, a picture tells 1,000 words. And I really think that Giraffe, both the work we've done and the work that I would encourage you to do in contributing to this project, or in just taking these visualizations and using them for your own purposes, helps you tell your story. And so with that, I will come back to stopping share. I've probably wrapped up far too early, Chris, so you're going to have to dream up intelligent things to say.
No problem. I mean, there is a question from Keith, and Keith was just wondering if there was any plans to have a version of Giraffe for Angular, for supporting existing Angular apps.
One of the things we've been thinking about is kind of what do we want to do in terms of, do we keep working on the visualization library itself, or do we also start looking at, is there an easy way for us to basically give you the code to integrate with other visualization libraries? And so it's a bit of a balancing act between, in the case of Giraffe, where we've written the entire visualization library ourselves, along with the community, versus being able to kind of leverage the power of other visualization libraries, and making it really easy to put those two together. Because one of the things that I noticed was, in some of these cases, it's like, okay, so it's only 4 lines of code, but it'd be great if somebody told me those 4 lines of code. And so that's one of the things we're beginning to look at more of. What are the things where just by providing a really simple kind of mapping of, you have this data that comes in this way and it's going into a common visualization that way, how easy can I put that together? So no specific plans on Angular, but certainly something that we could look into, how would we make it easier for more common libraries.
I think when we all started, we just thought about time series data and thinking that, that can provide you with so much insight and that's good enough. But I think what you and Ryan have pointed out is that if you can add kind of like another dimension or more context, Ryan talked about, other data sources, right? That can help you to understand, maybe it's like where the servers are actually located, or what bit of machinery was just upgraded with this piece of equipment, and that's potentially causing the weirdness in your time series data. And then what you showed was showing time series data not just with your typical time series graphs, but showing it with geo data. That's just like another dimension. I mean, are there other dimensions or other data sets that you've thought about or you've heard from other people that might be of interest to our community?
Yeah, that's a great question. Because really what you're trying to do, and we've talked about it a lot, is trying to kind of turn data into knowledge. So how do you get kind of the full value out of the data? And a lot of that is around the context that surrounds it. So whether it's geographical information, or a lot of it is the idea of just kind of the more identifying information. So we see it ourselves, like we look at our, we're monitoring the cloud through our dashboards and having context. Like one of the things that will happen is we'll see a blip in the, we'll see a blip on some graph and you're like, I wonder what was happening at that time. And then someone will chime in and say, oh, we were doing a deployment. And so that would have a, maybe a temporary impact on one of the servers because it kind of, it rebooted or something. And so having that context around your data, I think is super valuable because it shows you what to look at and then what to ignore. So being able to get a way of saying, don't worry about this particular thing, it's irrelevant. And I know some people have been asking, and we are actively working on annotations into Cloud 2 for exactly that reason, to be able to say, don't worry about that graph, that's where I accidentally poured coffee on the laptop, or whatever. So trying to say, or this is the one we should be looking at, this is the area we should be going. So all of that, being able to kind of add knowledge to support the raw metric. Because raw metrics it's really hard to kind of remember the context to know how to interpret them.
So you kind of touched on this a little. So so you can add data to give you more context, but sometimes taking away data also gives you some context. And you talked about, processing that data with Telegraph. Where does it make sense to process that data in Telegraph versus with the Flux query that you mentioned? What is there a best practice for that? Are there some recommendations?
Yeah, it's so there are probably a couple of different things that factor into that. One is the sheer volume of data. So you don't want to be writing a whole ton of data if it turns out to be irrelevant. And so it becomes a question around, maybe I don't have a need for that data now, but is there potentially a need for that data in the future? And if there's potentially a need for that data in the future, then you're better off writing it in so that you have it. So don't kind of pre-filter pre-filter at the edge. If you might say, okay, so maybe my dashboard, I didn't care about, whether that train took bikes or that train didn't take bikes, but somebody else may care about that in the future, in which case I should leave it in. Versus, say, the example I gave of Starlark, it's like, there's nobody who particularly cares, is it the word leaving instead of a zero. And so that's a good example to kind of filter out. So yeah, it's a trade-off. You don't want to be sending tons of data that is irrelevant. At the same time, you don't want to be kind of losing, as they say, throwing the baby out with the bathwater. You don't want to find that you've stripped the data down so much that you end up kind of in the cloud going, it'd be really great if we had whatever, but we pre-filtered it all at the edge.
What about, what is your recommendation with timestamps? We get a number of people that say, InfluxDB already adds the timestamp, don't worry about it. Some people say, no, I really need to get the timestamp from that originating source. What are some best practices?
I think, again, it comes back to kind of what is the importance of the timestamp at the edge? And in some cases, it may be critical. I need to know at what time did this device report this status, not at what time did it show up in the cloud. So there may be other cases where you're like, actually, I don't need to know that. That's not actually relevant to this metric and it's not important. I would say in general, I think getting the timestamp from the source is probably more meaningful. But another area that can skew that is you might find it's like, hey, I can't actually trust the time at the edge because my clocks drift, or that it's inaccurate. I'm going to get a whole bunch of things claiming they happened on January 1, 1970. So I think you kind of have to look at the reliability of the time at the edge. And so the fact that we can timestamp the data as it comes in is definitely, definitely a powerful and valuable thing to have. But you also, there may be times where the timestamp at the edge is more important.
And I know that question probably felt like it came out of left field, but as you were talking, it just reminded me of some questions that I often hear from users when they talk about, bringing data into the system. So I appreciate your answer. You've also mentioned that you've made some changes to your team. So what area of focus should the community expect from your team?
Great question. I've grown the team. We've been hiring like crazy. So we've been hiring in all teams. So let me start with the data acquisition team, and I'll give Ryan a little dig on this one. So Ryan conveniently renamed my team last year, and he said, "Oh, they're not the Telegraph team; they're the data acquisition team." And I think he somehow hoped that by renaming the team, they could expand their scope and charter. And so it's been a while coming, but we are. One of the things we've been looking at is, while Telegraph is hugely powerful, it's an incredibly sophisticated way of gathering data in such a way that you can get it up to the cloud, coming in through all different formats, transforming it along the way, sending it out in all different formats. But Telegraph itself is only one approach. There are other ways and other use cases where people need to get data into InfluxDB that are not, they're not as amenable as an agent-based solution like Telegraph. We're seeing a lot of data migration cases, bulk data migration, where customers are saying, "Hey, I really like that new cloud, your cloud service. I want to start using it, but I've got all this valuable historical data and I want to get that over." And so looking for efficient ways to be able to move historical data into our cloud, looking for ways for people to have, maybe they've run an instance of open source at the edge and an instance of, and our cloud, and then having those two work together as really part of the same ecosystem. So while there are some use cases where Telegraph at the edge is hugely powerful, there are other use cases where InfluxDB at the edge is hugely powerful, and knowing kind of when to use the right combinations of those and mixing and matching. And so I'm really excited, as the team is growing, to be able to take on more of those use cases and think more generally around how do we acquire data, so I can live up to the potential of the broader charter that Ryan gave me. And then on the UI side, the UI team also has expanded, welcoming a bunch of new employees into the UI team. A lot of what we're looking at there is kind of around this kind of mix and match, which is, let's not assume that everyone wants to use our web UI the way it is. So let's just think more about the use case of a developer. And so they may be using our UI as they build their app, but ultimately they will be delivering the service through their app. It'll be their app using time series data at its core. And so working through kind of what does that mean for our UI? How do we enable this developer community, as opposed to just kind of, hey, come in and build your queries and look at our dashboards, has been really interesting to see as we move forward. And so I think over the next year, we're going to have a lot of capabilities to really help the developer and help them kind of integrate our solution into their world, rather than us just focusing on kind of how you would use it through our UI.
Cool. So we do have a couple questions that have come in. So Joel asked, if you're streaming events and publish an event in the past, you can also probably miss an event trigger, referring to capacitors subscribing to a stream. I can understand for the ingest timestamp, but I might be understanding how those windows and periods are populated.
Yeah, and that's a great example. So yes, we often see cases of people with late arriving data. So we've got a customer who has ships out out at sea, and basically they gather data locally and they process it locally on the ship. And then when they come back into harbor and they're in range of a better network, then they upload that data to the cloud. And so in that case, they're definitely getting it. That data is arriving late. So yes, Joel, these are not interchangeable. The timestamp at which a data arrived to the cloud and the timestamp at which it was collected. And in that particular case, they do have, they easily have late arriving records coming in, which are still very relevant data.
Yeah. Do you have the next question in front of you?
I do. Do you have customers that use machine learning add-ons that learn patterns of repeating data over regular intervals of time with the ability to detect when new data drifts outside the trained norms?
I think the one, oops, sorry.
No, you go ahead.
The one that comes to mind is one of our speakers, actually two of our speakers from InfluxDays 1 year ago. Allison from Robinhood actually talks specifically about this. So Keith, I would recommend taking a look at that video. And then also ING Bank also talked about that. And then there's a couple other use cases that surround this as well.
Yeah, it certainly is a, it's a natural case, because that's really what, a lot of these, what you're trying to look at is what's different. So I've got kind of what is the normal behavior and then what's different, and trying to define what's different so that then you can alert on it. So I mean, that's one thing I talked a lot about, kind of visually looking at these graphs. But certainly a lot of the power of the platform is around the ability to not sit there watching graphs and to be able to have it alert when something diverges from the expected behavior. Because, while we may love all this data, we don't want to spend our days just sitting looking at it.
So what does your team need from the community?
Input, actually. So the contributions, feedback, use the service, tell us about it. We really, as we drive forward, we get we get a lot of our inspiration from the community. If they'll say, hey, I'm trying to do this, or even tell us, I was able to do this, but maybe it was a bit more complicated than it should have been. Maybe it took more hop, skips, and jumps than it needed to. And so knowing that the community is really using the product is really exciting. As an engineer, I mean, there's nothing worse than you build some cool piece of technology and it just, nobody's using it. And so the, engineers get excited and get inspired by knowing that their stuff is being used. And so community feedback, good or bad. We want to know what doesn't work, but we also want to know what does work. We want to know what you like. We want to know what you hate, because that's what motivates us. That's what motivates us to keep showing up and to keep building.
I think the tricky part with all the work that your team delivers is that there's so much. There's so many really great releases that come out. So I would recommend to everybody on this call, take a look at all these Telegraph plugins, take a look at Giraffe, take a look at all these contributions that this team has made. And we'll be sure to do a better job of promoting it so that it'll be easier to take a look at these things. But I'm always surprised. Every time I see the release notes, I'm like, oh, wow, there's even more. And it's not just additional plugins, but there's also enhancements to some of the popular plugins as well. So it can be overwhelming, but I think, I think the team that you've pulled together, Barbara, they're really eager to understand and listen to the community. And at the last community office hours, was it last week, I guess? Jesse and Stephanie, and I think there was one more person from your team that were actually on the office hours. So I do recommend that people join, these sessions and provide your feedback in whatever form, that you can. Docs, questions, code contributions. I think Barbara will take it all.
Oh, absolutely. Yeah, and you don't want people to feel intimidated. You don't want people to say, mine's a dumb question, so I won't ask it. It's like, ask the dumb question. Or if I don't know enough about React to be able to actually contribute, that's fine, don't contribute, but maybe send us, a hand-drawn scribble. Hey, I would love it if there was a visualization like this. I don't know quite how to describe it. And that, that may inspire the engineers. If nothing else, one of the things we do internally is every once in a while, we'll do an internal kind of hacker day where we just let all the engineers, it's like, don't do your usual job, do what you'd like. And they often will pick up ideas that they heard mentioned in the community, and they'll go, oh, let me give that a try. And we get inspiration from that too, of being able to see kind of what the community is interested in, and then the engineers will be like, hey, yeah, let me try putting that together, and that often turns into product. So yeah, ideas come from everywhere.
We have one last question. I'll let you read that out.
Jill Tain, I apologize in advance if I've butchered your name, has mentioned high resolutions graphs for displaying pertinently latency real information instead of noise. Is there any planned yet in the UI widgets and in the engine aggregation for such graphs? Not sure I'm fully following the question. Certainly, we have a lot of examples of where we use the power of Flux to filter. And so the question is, how do you know what you're filtering to get rid of noise? And so I think that is something that's fairly sophisticated to do well, and you need to kind of understand your data, but it is incredibly important. So trying to filter down to, well, what is the real information instead of the noise? So I don't know that we've anything specifically there, but I'd love to follow up offline because I may have misunderstood the question here.
Cool. Well, Barbara, it's a pleasure like always. It's so great to hear from you, and your explanations are just, I think it makes everyone feel like they can do it. And so I encourage everyone, try out some of these libraries, try out some of these visualizations outside of our UI, try it in React, even if you're not that familiar with it, and provide the feedback. I know the team is really eager to hear from everybody. Any last thoughts, Barbara?
No, just if I can do it, you can do it. It doesn't take huge sophistication, and then and also give us the feedback on it. But no, I'm definitely inspired to have everyone give us great feedback. So
awesome! Thank you so much, Barbara.
All right, thank you.